Dr. K. Paranivelu, Professor at the Center for Environmental Studies and Director of Center for Climate Change and Disaster Management, Anna University, Chennai. He obtained his PhD degree from Indian Institute of Technology, Madras, Chennai. He worked as project officer for a brief period at IIT Madras and moved on to the Center for Environmental Studies, Anna University in 1992. He was a visiting professor at Chungam National University, South Korea during 2007. He has been teaching courses on environmental chemistry, environmental pollution control, and instrumental methods of analysis since last 27 years. He has guided 75 students for ME and MSc, 4 MPhil, 2 MS, and 15 PhDs. He has published 135 papers in journals and 90 in conference and symposiums. He has received several awards in national and international levels.
Welcome to the lecture series on chemistry of environment. We are discussing the chemistry of aquatic system. Earlier class we have discussed the various processes which actually determines the mobility of chemicals involving both metal ions and organic thing in the aquatic system through various processes. Now in this class we are going to discuss yet another chemical process, namely photochemical reaction and hydrolysis reaction, especially mainly for organic thing, how important in determining the fate of this chemicals ultimately in the aquatic system. Let us start with photochemical transformation of chemical in the aquatic system. And this is already we have seen a lot of information or chemistry behind the photolysis of atmospheric chemical transformation. And photolysis of organic compound in the hydrosphere commonly occurs usually on the top of the water bodies, that is surface film exposed to sunlight on the top of the water. So, the organic compounds actually present in the water absorb this light, may be visible or UV, and ultimately initiating many type of photochemical reaction. So, the first of this is that reaction is initiated by photochemical process in which a photon of light is absorbed by the reactive species actually present in the water. That is, electromagnetic radiation is absorbed by the chemical species that become excited. The excited molecule is usually highly reactive, and next immediately it will generate what is a free radical species with an unpaired electron will be generated, as we discussed in the atmospheric chemistry. Once this is free radical is generated, the third point is chain reaction will be initiated, that is, which can multiply manifold of the effect of single reaction initiating in the event. Okay. So, it is a series of reactions actually connected to the photolysis. First, absorption of light, the absorbed chemical species form, next reaction generate free radical, the free radical generate chain reaction, ultimately many chemical species undergoing variety of chemical transformation through absorbing light, photolysis, which is happening actually naturally in the environment. For example, the pesticide or dioxin compounds or any other chlorinated compounds actually present in the aquatic system, they are capable of absorbing light, and what happens is if water is available and proton is there or hydrogen is there in the photolysis reaction ambient thing, immediately it will react and generate hydrochloric acid, and ultimately what happens is there is a dehalogenation reaction is initiated. This is one of the future of dehalogenation reaction through photolysis, eliminating a molecule of hydrochloric acid, and ultimately what happens is one of the chlorine in the organic compound becomes replaced with hydrogen. So, these type of reactions usually dehalogenation brought out by photolysis at a appropriate condition. This is a whether it is a dioxin or chlorinated pesticide or any other organochlorine compound is there, this reaction is one example. Other chemicals then in the atmosphere ultimately they will be degraded, converted into carbon dioxide and water through aldehyde formation or and subsequently acid generation. So, photolysis is a one reaction, especially for organic compound. Next type of reaction which is happening in aquatic system is hydrolysis. So, water is a medium, and thus all the pollutants present in the water system are capable of reacting with the water. Okay. Simply they won't present some of the compounds they have, whether it is organic or inorganic, likely to react with the water. So, the hydrolysis reaction is one of the reaction taking place in water. Metal ions, for example, if they are present as a aluminum or iron, they will undergo hydrolysis reaction and forms metal hydroxide. For example, aluminum 3, if it is present, it reacts with water and form aluminum hydroxide, which is an insoluble precipitate. At the same time, proton is released. Same way, iron also will undergo reaction, hydrolysis reaction, and gets converted into insoluble compounds. So, aluminum, iron, or with any metal with a high oxidation state is likely to be converted the respective metal oxide or metal hydroxide. In fact, alum used in water treatment is added as a aluminum hydroxide salt for water thing. Simply aluminum sulphate is dissolved in water, it forms aluminum hydroxide salt used for water treatment. Similarly, FAS, ferrous ammonium sulphate, is a compound. Acid is added to prevent hydrolysis. If you don't, when you prepare FAS in laboratory, simply by adding water, definitely the next day if you see, it will be a green color precipitate, ferrous hydroxide will be formed. So, to prevent this hydrolysis reaction, normally we have to add sufficient acid, otherwise we cannot prevent hydrolysis, it will be precipitated as a ferrous hydroxide green color precipitate. So, not only in the hydrolysis reaction for organics, including for organic compounds also will undergo variety of hydrolysis reaction. Certain things are, for example, if you consider calcium carbide, if a moisture is there, it will undergo hydrolysis reaction generating acetylene gas and lime. This is one of the thing used in artificial ripening of fruits, which is very dangerous, which should not be practiced, okay, because the acetylene gas will bring out the ripening of the fruit, which is not good, plus lime also will be present. Okay. So, calcium carbide, if moisture is there, it will undergo hydrolysis reaction, and a variety of other organic compounds also undergo hydrolysis reaction. For example, ester will undergo hydrolysis reaction, especially oil what we use also belongs to this type. Proteins molecule, all these things, first initial reaction for the degradation is hydrolysis reaction. Once hydrolysis set in, definitely they will be split into simple compounds, further easy degradation, biodegradation is possible. So, for the biodegradation to start for organic compounds like oil or proteins or carbohydrate, everything, first initial reaction is hydrolysis reaction, followed by biodegradation of organic compounds. If we consider foodstuff, we take a lot of foodstuff which are consisting of carbohydrates, that is polysaccharide compounds like starch and cellulose, disaccharides like sucrose, everything we take as a food material, and all these things are also likely to be end up as a waste, and these type of carbohydrate materials will be easily hydrolyzed to monosaccharide, and ultimately the monosaccharides are very ideal food for microorganism, and the waste ultimately can be easily converted into carbon dioxide and water, easy biodegradation. Same way, proteins will be hydrolyzed, converted to amino acids, the amino acids will be further degraded to amines. Oil too, oil also, triglyceride on hydrolysis gives glycerol and fatty acids, a process used for soap manufacturing. So, all this food stuff what we use at home end up in the sewage, ultimately they goes to biological treatment, and before this easy hydrolysis of all these compounds is happening. The hydrolysis reaction we see monosaccharide, these are the certain monosaccharides likely to be present, like glucose structure is given, fructose, galactose, maltose, all hexose sugar, which are all ultimate product of hydrolysis of polysaccharide or disaccharide. Just to see the structure of two disaccharide, this is a glucose molecule and this is a structure of the lactose molecule. These on hydrolysis, suppose sucrose is hydrolyzed, it will give you a molecule of glucose, one molecule, the other molecule is fructose. Water add, hydrolysis is the addition reaction of water adds this across this oxygen linkage, this is split and this is split. Same way lactose sugar, which is actually present in dairy wastewater, and if you add water, hydrolysis reaction will take place. Glucose and galactose is another sugar molecule. This is also a hexose. So, the lactose is one of the industrial dairy wastewater product which can be split by the hydrolysis reaction, converted to glucose and galactose and ultimately easily biodegraded. Similarly, maltose sugar is also readily hydrolyzed to give two molecules of glucose, because maltose is nothing but composed of two molecules of glucose, whereas sucrose one molecule of glucose and one molecule of fructose, whereas lactose one molecule of glucose and one molecule of galactose sugar. And if we consider the polysaccharide, we have two type of polysaccharide. One is starch. Okay, the structure is given here. It is a polyglucose molecule again, amylose molecule, and another thing is cellulose, which is also consisting of cellulose molecule again with a glucose molecule. The units are here. The difference is the linkage here, how it is linked in the starch and glucose is different. And if you look at, basically both are linked with the glucose, but in the glucose molecule is repeating unit, whereas there is a change in hydrolysis behavior. Suppose we take starch, it will be hydrolyzed, ultimately converted into glucose, human beings. That is a easy way, but whereas if we take a cellulose fiber, our intestine is not having particular enzyme to cleave or bring the hydrolysis. So, ultimately it comes out as undigested cellulose material, whereas animals like cow and other things, they take this cellulose and they have intestinal enzymes which is capable of breaking this one and converts the cellulose linkage in the of glucose and ultimately to glucose. So, that is a difference between starch and cellulose. Human beings, we are capable of only digesting or bringing hydrolysis of starch molecule, not cellulose, whereas animal, they have the ability to bring the hydrolysis of cellulose molecule also. So, to summarize of this carbohydrate, how they undergo hydrolysis reaction, okay. Disaccharide, starch and cellulose and hemicellulose, if you see all these are disaccharide and polysaccharide molecule, everything is subjected to hydrolysis. The initial reaction is hydrolysis, hydrolysis lead the monosaccharide, maybe a hexasucrose or penta sugar like arabinose and xylose. They are the component of this hemicellulose molecule, arabinose and xylose, whereas starch, cellulose, disaccharide, everything consisting of hexose only. Ultimately, they give on hydrolysis, give the respective hexose molecule as a product which will undergo further biodegradation. Same way, proteins whatever you eat also end up as a waste, and ultimately they will also undergo degradation in the wastewater through this process. Protein will be converted to the polypeptide and then polypeptide to dipeptide and dipeptide to amino acids. That is a route through which hydrolysis reaction brings in. The amide molecules also will undergo hydrolysis reaction, form the respective organic acids and the amine. The amide linkage is broken here and it is converted into the respective amine and acid. So, the dipeptide linkage is broken here with amino acids, and you get a peptide linkage separately. Okay. All these things are brought out by enzymes available naturally. Enzyme hydrolysis bring out this. In fact, if you consider this process of hydrolysis, it is a reverse manner of protein synthesis. So, the protein is synthesized from amino acids to dipeptide, dipeptide to polypeptide, and then to protein. This is a cycle, but here the degradation we are reversing it ultimately through enzyme naturally present bring out this enzymatic hydrolysis, leading to the amines. If suppose any dead animals is there, the enzyme hydrolysis takes place and bring in the degradation of amine, and sometimes you might have noticed that dead animal smell, that is due to the production of various kinds of amines emanating. Amines are bad odor compounds. So, that is responsible for the smell from arising from dead animals. That is ultimate product of the hydrolysis of protein based one, because our body contains a lot of proteins, ultimately that is released as amine, that is responsible for the bad odor of dead animals. In addition to the food materials, what we waste reaches sewage, like food materials consisting of carbohydrate and proteins. In addition, we discharge large amount of soap also into sewage, that also reaches and causes environmental problem. These kind of soap materials, if you see, look at the nature, are salts of long chain fatty acids such as sodium cerate. As vegetable oil, this also belongs to fatty acid series. The soaps are used for cleaning purpose earlier, and this is actually good with a good water where hardness is very low. So, even still soap can be used. The cleaning action of soap usually results from emulsifying power caused by the dual nature of the soap, that is, it consisting of head and tail part, that is actually helps in cleaning or removing the dirt. That is, the presence of oil, that is fat and other thing, that is water insoluble organic material, the tail part of the anion tend to dissolve in the organic matter, whereas the carboxyl head part of this soap solution remain in aqueous solution. So, actually because of this head and tail of this soap material, dirt is cleaned actually from the fabric. But when using soap, actually the soap is derived, if you consider basically vegetable oil, on hydrolysis with sodium hydroxide or potassium hydroxide, they will form sodium cerate. That is, glycerol is the one hydrolysis product, as I told you before, and another one is the fatty acid salt. The sodium fatty acid of the soap is water soluble, but if you use water containing hardness, that is calcium, magnesium, what happens is this sodium stearate type of vegetable oil fatty acid, and it is converted into water insoluble calcium sulfate salt of the stearic acid. So, this is responsible for not action of soap, because of the calcium compound replaces sodium, binds and form an insoluble precipitate. This actually is a hindrance to the soap action. Otherwise, it is a wonderful material in which it can be easily biodegraded, the fatty acid. And soap has a distinct advantage from the environmental standpoint when compared to the modern synthetic detergent what we use, because these soap material, if they reaches the sewage treatment plant, eventually easily biodegradable, okay, and hence the soap material, that is fatty acid, is completely eliminated from the environment, no residue are remaining. So, this soap material actually derived from vegetable oil. This vegetable oil on hydrolysis with the alkali, it forms a sodium salt of the soap plus glycerol, and this sodium salt will undergo easy biodegradation, ultimately cause no harm because of its easy biodegradable nature, completely eliminated in the sewage treatment plant. But now, because of this hardness problem, what we encountered is we are switched over to synthetic chemical. This synthetic chemical for soap replacement is called detergents. Okay. If you see in the earlier we have discussed carbohydrate, proteins and oil, that is all are easily biodegradable, no problem in treating or managing them in the sewage treatment plant. But if you look at it nowadays, like detergents for soap replacement, many synthetic chemical compounds have entered our day-to-day operation. Ultimately, they are all ending up the treatment plant where there is a difficulty in managing this synthetic chemical. The same thing with the detergents, synthetic detergents, which is a replacement for soap, because these synthetic chemical along with the detergents, many other pesticide and other polyaromatic hydro compounds, all those things remain in the environment for a long time, that is persistent organic compound. They are all called as a POP, persistent organic compound, pollutant, and these are of great concern to environmentalists because of the synthetic organic compounds are accumulative and toxic, poisonous, and ultimately may reach objectionable concentration or level in water and in aquatic life. So, this is one of the challenge to the environmental people and eliminating these compounds from the environment after use. So, let us see how this what is synthetic detergents, how they are managed and what are the status. Okay. So, wide variety of synthetic detergents have been accepted as a substitute for soap in managing the hard water, because many part of the globe also the hardness in water is increasing. So, the soap is not good. So, whereas in the synthetic detergents work or clean the dirt even in presence of hard water, and as marketed most of them contain 20 to 30% of active surfactant and 70 to 80% of the other things are builder, and usually these builder materials are used such as sodium sulphate, sodium tripolyphosphate, sodium silicate and other material, usually in the purpose is to enhance the detergent properties of the active ingredient. So, that is also actually present along with the synthetic detergents, and especially if you look at the polyphosphate present in the synthetic detergents undergo fast degradation by hydrolysis. Polyphosphate compounds are converted into simple orthophosphate on hydrolysis. Even though these hydrolytic products do not pose any threat to aquatic animals life, not very high toxic or something, but they act as a nutrient for plants and thus causing along with the nitrate what is a problem called eutrophication or algal bloom. Okay. That is excessive growth of plants is one of the problem due to this modern synthetic detergents, in which the tripolyphosphate is mainly responsible for this eutrophication issue along with the nitrate. And if we see the main active ingredient, the detergents, we have different type of synthetic detergents like compound containing cationic detergents and anionic ones containing sodium lauryl sulphate, and then non-ionic surfactants also available in the market. And of course, cationic detergents are used for very special purposes, in which not only cleaning, even this cationic surfactant can act as a disinfectant also. Okay. So, it is used for special purposes, and non-ionic also only for certain application, whereas most commonly used is the anionic synthetic detergents, that is consisting of sodium lauryl sulphate is the one compound. Apart from this one, both amperlite type of detergents also sometimes available in the market, that is containing both cationic and anionic. So, the anionic surfactants are the most dominating one, all based as a sodium salt, and this one easily ionize in water to use to give negatively charged surface active part, and the sulphate and sulfonate is the other part. So, long chain alcohol compounds usually treated with the sulfuric acid to produce sulphate salt, that is an inorganic ester, with the surface active properties. And one such compound is lauryl alcohol, dodecyl alcohol, which is commonly used, and the surfactant is sodium lauryl sulphate with a molecular formula C12H25OSO3Na. This is a sodium lauryl sulphate, one of the most commonly used one even in laboratories. And sulfonates are usually derived from esters, amides and alkyl benzene. The esters and amides are organic acids usually containing carbon atom from 16 to 18 carbon atoms in this main thing. And there are variety of synthetic detergents also available in the market, and if you see various things. And the past, usually alkyl benzene sulfonate, popularly called ABS, okay, derived largely from polymers of propylene, and the alkyl group which is average 12 carbon atoms, and usually this is highly branched one. The benzene, alkyl benzene sulfonate is a highly branched one used earlier. And now we have gone for LAS, linear alkyl benzene sulfonate based type of one. This is what the currently used, and the structure of both are given here. The structure of the ABS, alkyl benzene sulfonate, and linear alkyl benzene sulfonate is given here. And here the ABS, it is branched, whereas it is not branched here. And the important message here is, if you look at the synthetic detergents, the biodegradability, ultimately what happens in the environment. The ABS compounds, because of the difficulty in biodegradation, because the benzene ring are attached principally to tertiary carbon out of the branched chain of the group. So, that makes it somewhat biodegradability poor. Whereas, if you see the LAS, that is linear alkyl sulfonate as shown in the diagram before, here it is easily biodegradable, because the benzene ring is attached primarily to secondary carbon atom. This makes this process easily biodegradability of the process very easily towards LAS. So, LAS, linear alkyl benzene sulfonate, are used nowadays, is environmentally friendly. The earlier one, that is the ABS, is a problem creator for environment. Ultimately, the escape from treatment plant and the residual concentrations are very high and contaminate the environment. To sum up, in this lecture we discussed about two important processes which are essential especially for organic compounds. One is photo transformation of organic compounds through dehalogenation and other thing. The other one is hydrolysis, which is preliminary essential step for ultimate biodegradation of compounds. So, these two processes determine the mobility as well as complete degradation or intermediate products is depend on how active they are. And the photolysis, the first step, usually chlorinated compounds end up in dechlorinated, that actually reduces the toxicity. And if we consider hydrolysis, that is very much essential for easy biodegradation of the compounds. We have seen the domestic wastewater, what we discharge, food materials consisting of carbohydrate, proteins, oil, everything first step hydrolysis, and remaining part is easy undergoes degradation. Same with soap. Soap earlier was a very ideal material, environmentally friendly. Because of the hardness issue, we have switched over to modern synthetic detergents. That is actually one of the issue, environmental issue. Even now efforts have been made to eliminate the non biodegradable ABS to easily biodegradable LAS is possible, and that way somehow we have overcome the environmental issue of using the modern synthetic detergents. So, with this we complete the end of this session on degradation of both natural products and synthetic detergents. We have remaining thing will continue in the next class.